This material is made available to you by or on behalf of the University of Melbourne under Section 113P of the Copyright Act 1968. It may be subject to copyright. For more information, visit the University Copyright website.
It suits me because I'm informal and lets me off the hook, that I don't have to give a very formal introduction. Javier said he's actually going to talk about himself during the talk, so, over to you.
Thank you very much, Leon. Thank you, everybody, for coming today and spending some time with me. My name is Javier Turegano. I am an engineering manager at RBM Group, the people who runs realestate.com.au. Have you heard of us? Yeah? Some hands? Okay. You search for property.
I will say, try and speak more slowly.
I'll try. Okay. I'll try. It's hard. I am engineering manager at realestate.com.au. I run 4 teams there around architecture, infrastructure, delivery engineering, and authentication. But I want to start from the very beginning. I'm going to talk today about some of the things I learned in my journey to DevOps. Let me move my laptop over here if I can. Oh, power is not on them. 1 sec. Okay. So I want to speak about DevOps as an exchange of crafts. A long time ago, in a country far, far away, this is where actually I'm from, Spain, Albacete, a small town in the middle of nowhere. I started my career. That's my first job as a graduate student coming out of uni. And I landed a job as a PHP developer in an ISP. Does anyone know what an ISP is? Yeah, what's an ISP? Over Internet Service Provider. I don't think they exist anymore. They're being eaten by the Telstras and the Googles of the world. So we used to offer email and web hosting and things that are given for granted now. But this is actually not about me. It's about that one server. This is that one unit. It took weeks to build. You will start by figuring out what pieces you wanted to buy to build that server. Then you will make a purchase order, you get the server, will land in your office, then you will figure out you don't have drivers for this type of server. You will spend weeks finding the drivers, spend a lot of time compiling a kernel to make it work. You will spend a lot of time crafting really carefully a configuration for that one piece of machinery that will run over websites and email. And one characteristic of this server is that it's a pet, because it has a name, and you nurture it, and you care about it, and you're really worried when it's sick. And if it dies, it's really, really sad. So you try to keep them alive as much as you can, because they are really precious to you. A few years later, I moved to Madrid, the capital of Spain, and I started working for a Linux consultancy company that worked for the government. I got an upgrade on my machine room, and this is what it looked like. I started to work for a lot of the government agencies, helping them to introduce Linux into their IT departments. We had many servers. Virtualization came along, so it meant that virtual machines can run inside those servers. So now we have hundreds of virtual machines. We had many developers that wanted to build code and build things and put them into our servers. And we had only few sysadmins. So we had pets everywhere. We had hundreds of pets to take care of. Imagine that was a really, really hard task. Around 2010, I traveled to Brussels for this conference called FOSDEM. Has anyone heard of FOSDEM? It's a free open source development conference. Happens every year. Hundreds of open source developers travel to Brussels and share their knowledge about the things that they do there. And I went to a systems administration room to talk about the things that we were doing. And then I met this one guy over there. He was a developer, but he said, I'm managing systems. Wait a minute, you're a developer. You should just be producing code. And he told me so much. That was the first time I heard the word DevOps. And for him, that was about applying dev techniques and tools to manage this fleet of servers. So instead of having to manually configure all his servers and going inside each one of them. If you're in Windows, it means you're doing something like this, clicking around and configuring things around. If you're in Linux, this means that you are building many configuration files. And that took so much time. So he was using configuration as code, putting all the things that needed to define the configuration of that server and put them under version control, the same way that he was doing with his code. And that was fascinating. And then he was using automation to distribute that configuration between the different systems that he was managing. I went back to my office and I wanted to do exactly the same thing. Started to investigate techniques and different tools in order to do the same thing. For me, that was the start of the journey and the first part of DevOps, which is how systems engineer or operations engineer were learning about the techniques that the developers were using to manage their things. A few years later, I got a random email in the internet from a recruiter that said, would you like to come to Australia? It's going to be fun. And he went to work for a company called realestate.com.au. First thing I did, I Googled Melbourne. I didn't know where it was in the world. And found an article in Wikipedia saying, Melbourne has been chosen as the best city to live for the last 5 years. I'm sold. I'm coming. I started to work for this company called realestate.com.au. At first, I was surprised. It's coming to work for a website, but they said they had 500 people working for them. I was like, what the hell do 500 people doing a website all day? Like, we can't do that with 10 people. Now, 7 years later, we're 1,800 people globally, and I think we probably need another 300 people to do what we want. So RE Group is a digital media business that specializes in property. We want to change the way the world experiences property. So we are headquartered here in Melbourne. We're in Richmond, and that's the main office. There's 700 people there, around 400 people in engineering. But we also have offices in 7 different countries in Southeast Asia. So we're in Indonesia, Malaysia, Hong Kong, China, and many others. And we also have investment in the US and India. It is considerably big. We have millions of visitors. We have hundreds of engineers, and we have thousands of systems. And it's a level of complexity that is really difficult to manage, and we couldn't manage that without DevOps. But what do we do? Someone described it really easily. We put pictures of second-hand houses in the internet, and then we put ads on top of that, and now we make money. In theory, we try to be your companion when you are doing the biggest transaction you're going to make in your life, buying a property, or maybe early on renting one. This is what a usual web page looks like. And normally, we get more visits now from mobile applications and mobile browsers than to the website. But if I put this in a vertical slide and I try to explain the many different sources of data that build this one single page, you can start to think about the complexity that this page has. So we have a lot of personal data, we have a lot of images, and we serve tons of images to the internet, and we have aging data, we have recommendations done through machine learning to figure out what all the properties you may want. We have investment data, and you can input your income and figure out what properties you could afford. We have information about equity data. At our scale, with millions of visitors, we cannot have a single system that holds all these data. So you can imagine each one of these as a big pocket and a big, massive amount of servers that are serving that data. But how was it all before DevOps? How was it a little bit before I joined the company? You may have seen this meme. It's about how DevOps started. On your left side, you have a developer. They want change. They want they're paid to build features. They are incentivized for change. On the other side, you have an operations engineer. Normally, are the people that run the website. They are the ones that are on pager whenever something breaks. Pager, you see in doctors, this one thing that we take away when we go home. And whenever the website breaks, we will get a signal, and we will have to jump in and fix things. So operations engineers want stability. They don't want change because it will break their stability. This is a typical delivery process. Like the developers will throw packages over the wall of confusion to the operations engineer for them to run and operate. And there will be a lot of friction between these two parts. And this is what normally won't happen. You work on my laptop, you work fine test, solves problem now. And this is what it looks like at night. Any Game of Thrones fans in the room? The night is dark and full of incidents. We used to have a wall in one of our parts of the office where it will say, number of nights with a full night of sleep. Do you know what the counter looked like normally in 2012? Zero. And do you know what your manager will say when you come in the morning in the office after being dealing with the incidents all night? Why are you late? So it was a terrible experience, and we did so many things to fix it. One of the things we did, if you want to follow how it felt, look at this picture. This is my friend Laxi getting on Payer on Friday night, and that's his face. This is him getting off Payer on the next Friday and handing it over to someone else. I'm being really happy so he's gonna get some sleep finally. If you are a developer, this is how it felt. You're alone. You just finished your coding. You're ready to deploy into production. You have something new, exciting features for our customers. There's nobody to deploy them. The office is empty. If he was a system engineer, which he was, he would be there thinking, the website is broken. I don't understand this piece of code. And I don't know why someone decided to push a change on Friday night while I was about to go to the cinema. So that's a little bit of how it felt. How we fix it for us at REA, software development is a team sport. It's not an individual activity. We are all there for the same reason. And it's not only to build, but also to run our systems. This is what a typical team activity looks like at REA. It's a bunch of people working in the same project. As I said, it's a team sport. But we have the concept of cross-functional teams. So not everybody in the same team has the same role or expertise. They're bringing different things to the table. We'll have a delivery lead whose role is to decide how we're going to split the work and how we're going to execute that work. We'll have a bunch of developers and a lead developer that are bringing that to life. We'll have a product manager that is answering the why are we building this feature. And then we'll have a system engineer, in this case in the corner. When I used this picture before, I used to say, we're in the middle of an incident. And guess what? What is the systems engineer? When I went back, everybody's like, oh, it's the guy in the middle, or it's and then I said, oh no, it's the guy in the corner. And this is how we do things these days. Developers are fully responsible for running our systems. But I have systems engineers that can hold them, and I have been working really hard to teach them and to bring up their capability to run code in production. I don't know if you come up with this phrase from Bernard Pogels, who is Amazon CTO and AWS CTO, and we follow this principle really hard. You build it, you run it. And it's very important because it brings that feedback loop alive, where whatever you build, you are responsible for, so you can ensure that the quality of that one thing is really high, so you don't get woken up at night. We also follow the principle of the two pizza teams. Have you heard of the two pizza teams? Yeah, over there. So normally when teams shouldn't be bigger than a team that can eat two pizzas. I know pizzas can be really big, and then the team could be massive. But then there's also people that can eat a lot of pizza. So the idea is that you get small teams around a product set, and you give them everything that they need in order to succeed at running that product. We have a full story in our blog by my friend Tom Paddington about how we teach developers and how we share our craft around systems engineering and raise their skills in order to be able to run and operate our systems. You can read it in our blog. Unfortunately, 40 minutes I cannot tell you the whole story. So that's some homework for you. But now, I'm going to move to some more practical examples. And this is one of my favorite interview questions I do to all candidates that interview with me. So here's a cheat sheet for you if you ever interview with me. It is called From Happy Project to Production Ready, and talks about automating the flow and delivery of value. This is one of our hackers. We run them every 3 months, and we get the whole company together to hack in new projects. So you have 3 days to work in whatever idea you have. You will come in front of everybody, you You will pitch your idea, and then you will get a team of people that will join you to build that in 3 days. On the third day, there's a marketplace. You will go there, and you will show your idea to everybody. If the idea is successful, you may get funding later on to make that project reality. Let's go back to our property details page. Let's imagine that we're on a hot day, and you're a team of developers who have decided you want to build a school data information for our page. This is the distance between the property and all the nearby schools, and it's provided by an API. Let's imagine that during those 3 days, you end up with something that looks like this: a Ruby API and a database. And the workflow looks a little bit like this. We'll have our property detail page on the right side, and then we'll have that page makes a request into the API. The API processes the request with the coordinates, looks in the database, and using the coordinates finds the schools that are nearby, and then returns some JSON to the page that gets rendered in something that looks like that. Does it make sense? Easy. But we didn't have this 2 years ago, and some developer came up with the idea and implemented it in Hackett. Now, you are interviewing, and we want to do this. How are we going to enable this cycle to happen? How are we going to enable change to happen in a regular basis in this code base? And how are we going to make sure that we can operate and maintain that service? That's your duty. So what's left? What's next to do? Any idea? You have code in a database that's running in your laptop, and you want to make it production scale so millions of users can use it. What's the next step? Deploy it? Yeah, that's one part. Something else? Testing? Yeah, good one. Something else? Okay, I'm going to try to put it in these 3 pillars that for me are really important bits of making this a reality. The first one is about continuous delivery. How do we enable the flow of new versions of code into production? The second one is about having the right environment so we can test that code. So we have development, staging, and maybe a production environment. So you can flow your changes to them, and you can get safety that you are doing it in a way that is not going to break the website. At the end, we'll have monitoring and metrics that will allow you to have some feedback about how your system is operating. And in case if it breaks, it will help you troubleshoot that. There's a really good book on continuous delivery. That one over there, if you haven't heard of it, probably you can take a look. Any questions so far? I've spoken a lot and didn't give you an option for questions. Okay, I'll keep going. If you have any questions, please put your hand up and ask. If not, it's boring, just me speaking. So let's build a continuous delivery pipeline. There's a couple of tools that you can use for doing that. We have Buildkite, which is what we use at REA, but there's also an open source version of that called Jenkins. Has any one of you used any of these tools? Yeah, excellent. Okay, come on. So we're going to start defining how we build that pipeline. So on the left side, we're going to have the process of the pipeline. On the right side, on the top, we're going to have the artifact that we are working with. And down here, we're going to have our repository with the different components that we have. So that developer that works in the Hackett project has handed over to you the code of the application, the dependencies, and a schema for the database. With that, you can just go to your laptop and build a version of that API. First thing we do, we chunk it in the source repository. We use GitHub. There are many different ones that you could use. So we can track versions. Second thing is we execute the build process so we can have something that we can move around. That will use the dependencies over here to figure out what libraries do we need to bring in order to build our artifact. Or maybe if you are doing a compile language, it will go through the process of compiling that into something that you can execute. And we will use a build script that will keep in our source code repository. Going back to my friend developer in Brussels, we keep everything under source control. And we'll see how that's really handy when we have to do this process again and again and again. Then we run tests. Someone got that right. So we run some unit tests. There's many unit tests in the process, so we get some assurance that that code is going to work when we go forward, and we get that green tick on our artifact. So we have a little bit more of confidence that that artifact is going to work in production. Then we package it in a way that we can deploy it into production, and we will use, in our case, we use Docker. Have you heard about Docker? So Docker will allow us to package an image that we can run in different environments, and we will have that in the repository as well. So you can build that image anytime that you want, and you will be able to run it in your laptop, or you will be able to run it in production. That for us is now AWS. Okay, we're ready to go. We're ready to do our first deployment. So we'll have our deployment scripts down here that will allow us to do that. And we will deploy into a development environment. And wait, we haven't built one. At the moment we only have our repository. So let's build a really simple one. What will we use for that? We will use configuration as code. So we will tell Amazon through their API that we want to build this infrastructure. That will look like a piece of JSON or YAML, which will describe this environment. We will say, I want a server. I need 3 CPUs, probably 4. No, I don't know why 4. You need 4 CPUs, and you need 24 gigs of RAM to run this application. And all of that will be described in that one file there. Then you send that file to Amazon, and you say, make it happen. And that pops up in the environment, and then you have a test environment you can use. And what happens if that breaks? Go back to my first dungeon when I started working on, and I think about what happened when a server broke. It was terrible. It would take me a month to recover that server. What happens now? I just use the same YAML file to ask Amazon to build a new one for me. And it takes minutes, not weeks. This is amazing. Using the power of configuration as code, as well as the power of the cloud. So I can ask Amazon to provision one of those in seconds. And we're in a world where we are having cattle and no pets. So we don't give names to our instances anymore. We don't care about them. If they get sick, we shoot them. But then they come back again, and then we don't have to worry about them. Next step will be to run integration tests in that environment that we've just created. We can do that by adding more tests into our test directory. More confidence. We're building confidence on the top level of our artifact that this is going to work when we push it to prod. And we can do it in a constant way. We'll do some load testing in our test environment. We will throw hundreds of thousands of requests to this API to make sure that it's going to be able to handle the load whenever we put it in our main web page. And we will do some UI tests, and those can be sometimes manual, sometimes they can be automated. Again, we gain more confidence that we can deploy this thing. Now it's time to go to production. We have confidence that our test environment is going to work, and we want to build this new environment. But probably, for the scale that I've been talking about, this is not enough to handle that load, and probably it's not going to be able to support the number of requests and the level of availability that we require. What can we do? Well, we can just create more servers and deploy our application to all of them. And they will consume from the one database. We'll put a load balancer in front of them, so whenever a request comes, it knows which server is not busy and can serve that request. And we probably can find some extra availability by replicating our database to a replica, just in case that this one data center on the left goes down. We still have enough infrastructure to continue serving our API. Does that make sense? Any question? Okay. We have an environment. We can deploy into production. What will we use? Well, we will use a deployment script that is stored in our Git repository. Everything so far has been stored in there. There's not anything external. So if everything disappeared and we still have that repository, we'll be able to reproduce the whole thing. And now, when we execute a deployment script, ta-da, our Ruby app starts running in all of those servers. And we'll have version 1 of that application running. Now we'll validate it. Did it work? Is it all okay? If it is, perfect, we won. We'll have version 1 in production, and we can start sending traffic to it. If not, we will roll back There's nothing to roll back yet because it's the first version that we deploy, but we'll see how that plays out later. Our eager developers have a second version of the application ready to go. Now you know the work it took to build all this pipeline? Is it going to pay off now? Of course it's going to pay off. They will just push the code, dependencies, and the changes in schema into the repository, and it will flow by itself all the way into production. Passing all the tests will give us confidence that that new version is not going to break production. And now we're ready to go with the new version, and that has used all those files on the left side. So one way you can do the update is called a rolling update. You can roll the new version to half of your fleet of servers, and you can have both versions running concurrently. So now we have V1, V2, V1, V2 in our servers. And we test if that works, and if it works, then we continue rolling V2 to all our servers. And now we have V2 running in all of them. How are we traveling? Good? How are we doing with time? 10 minutes? Is it? Okay. Any questions? Drink my water. So now you can see the value of setting up these pipelines. And one cool thing I haven't talked about is that you can do this in code as well. You can put all the information about the pipeline itself in a piece of code in your Git repository. So if you ever have to rebuild this bar as well, you can do it from there. How will that file look like? You will have all the steps that we have defined here as code, as part of the pipeline. And then you can give this to BuildKite and say, build me a pipeline that looks like this. And then you can start flowing your code through that. Does that make sense? Sweet. So we've done from update project to production ready. But are we done yet? Well, let's talk about metrics and how important they are. We use a tool for us to collect all our metrics that is called New Relic. New Relic works as a library you deploy together with your code and will intersect all the calls between the different services in your application and will provide information or metrics that then get sent to the services and give you something that looks like this. On the top side, we can see how long is our transactions taking and a breakdown of where is it spending the time. So if you look here, it is taking an average of 17 milliseconds to share that request. That's not bad. And then you have a breakdown on where the time is being spent, middleware, Ruby, Postgres, and response time. So you can add all that together, but then you can find outliers. You can find where things are not working. If you had a spike in there, and it went, let's say, to 500 milliseconds, and maybe you want to fire up an alert and tell someone that the system is not behaving beyond their specifications. On this graph over here, we can see the throughput. Can you imagine why the throughput goes like that? Why do we have sometimes 3,000 requests per minute, and sometimes we only have around 500? Any idea?
Everybody likes to house hunt after dinner.
Yes, yeah. People love to browse property after dinner, and they went to work, and probably lunchtime. It looks a little bit like that. So this API will imagine that. One of the things I forgot to say is that the first thing that you do when someone gives you a task or a question in an interview, the first thing you do is to ask questions about it. So, hey Javier, you told me you want to put this into production. How many people are going to use this thing? How often can it break? Does it have to be up all the time? What happens when it breaks? How much revenue is flowing through this system? Because you will build in a different way depending on the answers to those questions. So you are getting more information about how to set this up, and you don't use a cookie cutter to offer a solution. So this is how we do it in some metrics. There's another element called logging. And you've probably seen a lot of logging coming out of your applications, and you can provide a lot of debug information out of them. You see them while you are developing, and how does you troubleshoot what new features that you're building are or not working? One of the things that we do with logging at scale is that we try to aggregate all the logging that we get from thousands of systems into that one pane of glass. In our case, we use a tool called Splunk, but there are other tools available that you can use to aggregate all those logs. Just imagine trying to troubleshoot something, and having to jump between thousands of machines to try to figure out where the problem is. So by aggregating all the logs into one place, we can troubleshoot this really quickly. Here's me looking at the school service API on my search bar and asking about the word Samsung. So someone called me and told me, hey, your API is not working when I use a Samsung device. So what they've done is query all the logs coming from all those applications and figure out what's happening with when the word Samsung is included in there. Can I look at the type of response, status 200? It means the request was okay. So then it will continue trying to figure out what's happening with those systems. And we do alerting as well. We don't have failures like doctors anymore. We use an app. It's called PagerDuty. And it helps us route the alerts to the right person. So whenever something breaks, we know which team needs to be alerted. And as I said at the beginning, we're trying to keep the teams that build the applications responsible for them. We try to route the alerts to the right person that is able to do something about them and knows about them. And we can do that as code as well. So we put information about which teams to contact into the Git repository. So there's a thing here to keep everything in the same place that the app is. So whenever you get an alert that says school service is broken, then you go to the school service repo, and you see all the information that is in there together, and anything that you need to do is normally going to be contained in the boundaries of that repo. In summary, I've talked about 4 things that I think DevOps stands for. It's exchange of cracks. We talked at the beginning how systems engineers learn from developers about how to automate things and how to keep everything in source control. Then I talk about how the system engineers taught the developers how to operate the systems, especially at scale. It's a culture of shared ownership. It's a team sport. It's about how we all collaborate together to build and run the systems in a sustainable way. I talk about optimizing the flow and delivery of value by building a pipeline that allows every single commit that we do to flow all the way to production without manual intervention. And I talk about operating sustainable services on the ways that we will organize our metrics, alerts, and logging in order to troubleshoot when something breaks. So where can you take this from here? There's a few things that you can explore. There's a few meetups that talk about DevOps and that welcome everybody that wants to join, like InfraCoders or DevOps Melbourne. I help run a community called DevOps Guild for women that are interested in DevOps. And we run workshops every 3 months. You can learn online thousands of resources about this. And I think a really cool thing is that you can try some of these tools and techniques using open source components, like Jenkins to build your build pipeline. You can use Docker to package your application. You can use AWS for free if you keep it under the free tier service, and you can sign up for an account and not pay anything as long as you don't start using a lot of it. And you can use tools like Logstash or Elastic Application Performance Monitoring to start to receive your logs and to start to see metrics in your projects. So you can play with all of these things that I talk about without having to be in a big organization. Now, it's questions time. If you have time, I don't know.
Yeah, no, it's perfect. So that's great. I've used your public API for accessing my property data, and noticed your load balancing only allows to get 50 pages back per request. Is there a way for me to get more than 50 pages back?
I don't know. I would guess it's intended.
That's your load balancing, right? But is there? So that,
I think it's probably a limit in the API. It's a way of putting it that maybe gives you 50 first, and you can. There's a way you can ask for the 50 next.
no, like it gives you a whole page. One page has 20 properties.
Right.
You go next all the way down to 50. You can never go next past.
Oh, so you want to
You
have
can get 1,000 properties.
So it's a, I'm gonna guess. I think it's intended so you don't get all the data at once.
I was wondering if you know about a way I can get it without.
No, we've discussed a lot about making that data available and building APIs for people that can build their own apps.
Yeah.
I don't think they ever took off, but it's a really interesting
Yeah, there's
idea.
no documentation of like, you kind of have to guess how to use the API.
Yeah, it's not intended for being used by externals.
Yeah.
Yeah.
Well, I managed to find it on Google.
Yeah, right.
Yeah.
Cool.
But, yeah. Anyway. Yeah.
Great, thank you.
That was a very detailed question. If you want
That's
more
okay.
general questions, that's also fine. About life in REA, or what skills people are looking at, or what are you impressed as an employer. You had a throwaway line somewhere of how to impress you if you're going for an interview, but the question now is an opportunity to ask whatever you want as a connection with industry.
Please.
What do you like about working at REA?
There's many things. My highlight is the learning culture. I think that for me is the biggest thing. I'll tell you a quick story about a European coming to work in Australia and in an environment like this, and then saying, hey, we're going to build a guild, which is an opportunity to exchange information about what we're doing and to learn from each other. And I think it's something you're going to learn from. You're going to do half during business hours, half during your own time. So we both kind of invest in it. And they say, no, we don't do it that way here. We'll do it during daytime. They said during business hours when you learn, because learning is part of your job. I'm like, wow, that's amazing. Okay, I'll take it. We will do it during business hours. So we've just launched what we call REA University, where everybody goes there. And I love how we have engineers teaching other engineers. And it's like they spend their own time to build training materials that we use internally. So we run our own AWS training, run our own Docker training, run our own Buildcat training. So, and that's in the engineers that are using the tools and really have deep knowledge about how to use them, share back with the new colleagues and people that want to learn more about other crowds. And that's pretty cool. I like that. Any other question?
I'll ask one.
Yes, please.
Because you work for real estate and you're not building stuff for externals, right?
I'm not building what?
You're not building apps for externals or other people's REA, right? Group?
Yes.
So do you think you have a certain level of, let's say, if you're encouraged or in terms of flexibility to add your own innovative ideas as part of this process, or if you're allocated into projects, you receive a list of requirements and you have to do so, to which degree that happens and how that happens in your company?
We'll have there's different ways to answer that. Like, we get money out of real estate agents, and they have their own needs. So there are probably sometimes dictating the roadmap of where we go. Sometimes we come up with innovation that then ends up in their hands or in the hands of consumers looking for property. Sometimes we come up with our own ideas. Sometimes it's about keeping the market happy and like coming up with things that make sure that we are on top of our game. But what we are doing now that's really interesting is to try to engage with consumers beyond the moment that you're buying. So try to be on top of the game and like during all your lifetime being a companion around property, which we are just in a point in time, which is when you buy or when you sell or when you rent. There's more opportunities around that. There's renovation, there's mortgages, there's so many other things around that that we are exploring. And it's about testing new markets and testing new opportunities. As well as when we look at Asia, Asia is a massive growth opportunity, but it's a completely different market. So we need to learn about how that operates. And then build experiences that match more those markets as opposed to what we know about Australia. Did I answer your question?
Yeah, absolutely. It's just wondering if there is a research team or someone that is trying to come up with new features, integrate with new devices as well. Or let's change this technology somehow. Or
Yes, we have an innovation lab that is headed by our chief inventor, and they are doing a lot of the VR, AR, and like machine learning and new things. And I think the challenge is about bringing those futuristic ideas that are over there and that nobody has access to into things that we can make money from. And there's like a balance between the investment in those two. But there is like innovation that is also visible. So if you think about something simple like a school service, this is such a useful thing for anyone that is consuming the website and wants to find property that they want to live in. It's a small tweak. It's So a lot of the times it's about thinking small improvements you can do that make a massive difference. Other times, is, for example, last year we entered the financial services space. We started to do home loans. And that's a whole different world. It's like a different level of requirements, it's a different level of thinking. This year we bought a data company in Sydney, and we started to source all the property data back into us. It's a completely different challenge, and now we have customers that are the 4 big banks. Again, completely different set of requirements and like different degrees of requirements. So
I'll ask a question on behalf
Yeah,
of the team.
please.
They said, how would you view on the various programming skills that people have? Does it matter if they've got experience in Java or JavaScript or Python or Ruby? Would one of those be more favourable than others in terms of interviewing?
So we are open to when we interview for software developers, we normally give you a code test that you can implement. And the code test is completely open, so it's implementing like a piece of functionality. You can submit any language that you want, and we will normally find a developer that knows about that language that can kind of rate your submission and look at it and learn from it, and then try to infer what your software engineering skills are, regardless of the language, and that's what matters for you getting in. The languages that we use internally, so you count with one of those, is a faster path into that. We use Ruby, we do Scala, we do JavaScript, and Java. They're probably the 4 main languages. If you do any of those, it's easy to integrate into a team, but if you're a good software developer and you have strong software developing skills, doesn't matter the language.
Other questions? Yeah.
What would be the best way to prepare for a whiteboard programming interview?
To do a whiteboard interview?
Program or paper. I had one recently and I didn't do too well.
Right. I said that for any interview, my take is you can come from 2 angles.
Yes.
Either you have experience in something or you have potential.
Yes.
So you need to exploit one or the other. So if you already have experience, you are showcasing what you know. If you have potential, then you are exploring and you are honest about it. You are like, I've never used this language, but let's do something about it. I'm gonna try. I'm gonna Google this problem. I don't know exactly. I think you want to go this way. Is going this way the type of thing that you're looking for? You're making lots of questions and throwing ideas around, even if you are not completely answering the question. You don't know exactly what it is. It's more about showing your thought process and how you're doing it. So you're continually talking about, this is why I'm doing this. I can put this in place because I think this is going to do that. I'm going in the right direction. What are the problems? I'm doing this because I think the requirement looks like this. And then you're kind of showing that you know how to think about the problem and you know the implications of the things that you're saying, rather than just step by step putting things in there. But that's me. I don't know. I have an interview for myself for a software engineering role for many years. I'm probably not the right person to answer that.
Other questions? More questions? We've got about, so take your advantage. Any questions? A good question?
I hope I didn't go too fast. But tell me the feedback if I was too fast.
Yeah, so they do have to give feedback, and which I'll be passing on. We'll relate back. You will. So it's still recording, so that will be up on there, so people can listen if it was a bit fast. So it's
Okay,
a chance
good.
to catch up. And you said you will send the slides.
Yes, I'll send the slides and yeah.
If you can do that, I think that would probably be helpful for people as well. So from my perspective, it's exactly the right message
Okay.
that you want. Your pipeline is exactly what the students can aspire to. So it's a challenge for the teams to actually produce a pipeline that you've got a year's project. Most of them don't get there,
Right.
but it actually really should get there. And I can see if you really want your system to be deployed, if you can get to that pipeline, you're going to have happier clients and increase the likelihood for longevity of the system that you build.
Totally.
Yeah. Okay, so maybe we'll stop there and let's thank Javier for a really great job.
Can you